Okay, hello guys. Happy Thursday. Good evening. This is our September week 3. Okay, how's everyone doing? We are continuing with our revision today. Okay, we are continuing with our revision today. So, hello, Bathmasri. Is this how I read your name? Are you from a different class or are you a new student? Okay, yes, hi Kaijun, how are you? Anyway, so, oh, you're from Saturday's class. I see. Oh, you mean you're from Hanyi's class? You're from Hanyi's class, is it? Okay, so if you're from another teacher's class, welcome. This is our week 3. So I don't know how's the progression, guys, but I am until chapter 5. Today we are doing chapter 5. Oh, Jennifer, I see. Okay, I see. Also means you're doing physical all the while. You're here for online to replace. Oh, I see. Hi, Julian, how are you? Good evening. Okay, cool. I hope you enjoy your stay. uh, is Saturday's class until here already? Because my progression is a little bit different. I might be a bit slow. I might be a bit fast. Who knows, right? So, guys, let's go to chapter 5. Let's go to chapter 5. Guys, I'm not going to spend too much time here in chapter 5 anyway, because this is really easy. Okay, and we just learned this like what 2 months ago. It should be still quite fresh. And yeah, as I said, this is really easy. Guys, do you remember what is exo and endo? Do you still remember what is exo and endo? This is a really simple stuff. Okay, so exo is releasing heat, cause heat exits from me. So I'm releasing heat. How your teacher just taught this in school, huh? Really? So slow, huh? Oh my God. Oh, you're in chapter 8 already. I see. Have you done the revision already for Saturday's class? Have you done this already? Because some teacher, they will do chapter 8 first. Oh, I see. Because they do chapter 8 first. They do chapter 8 first. My progression is a bit different. I do this first before I do chapter 8. So that's why there's a difference. Okay. Hi, Jingy, how are you? Okay, so guys, exothermic is exit. Endothermic is enter, means I absorb heat. Okay, guys, many students they tell me, oh, exothermic is when my water becomes cold because I release heat to the surrounding. So the air here becomes hot. No, guys, this is wrong. Exothermic means the chemical substance in the water will release heat. So the water and the surrounding gets hot. So guys, don't overthink this. Don't overthink. You just have to know if everything becomes hot. I don't care whether it's the cup or the water or the air. If everything becomes hot, that's my exo. Because the chemicals inside the water is releasing the heat, not the water, right? Let's say I'm in the water. Okay, I'm bathing in water. I release my heat to the water, so the water gets hot. I lose energy. Can you see the graph? Can you see the graph? I'm losing energy. So my energy goes down because I release it to the water. So the water gets hot. Am I making sense here? Am I making sense here? So endo is the other way around. Endo is the other way around. Endo is when I absorb heat. So the water gets cold. The air gets cold. Everything around me gets cold. I absorb energy. So my energy goes up. Okay, my energy goes up. Okay, you guys okay? Guys, give me a moment. Okay, sorry guys, I'm just a bit thirsty. Okay, guys, so moving on. let's continue with our exo example and endo example. Guys, this is really easy. I'm just gonna speed this through, okay? So we have respiration as our exo because I'm doing respiration right now. So around me, it gets hot, okay? Burning, I'm burning things. So surrounding gets hot. You see all this, the surrounding gets hot. Neutralization, let's say an alkaline. Freezing, when I become ice, the surrounding gets hot. Okay, your fridge gets cold, around your fridge gets hot. Okay, thermite, remember I said this, we use this to burn a hole through the cannon. Remember the Gustav gun thing? Okay, and then the hot pack, rusting. Rusting is under exo. Okay, guys in row. And sodium hydroxide, you remember what's your drain cleaner? You remember what's your drain cleaner? And then glow sticks. Everything, this one will release heat. Okay, next, endo is photosynthesis, baking or cooking. Okay, baking and cooking is when the cake absorbs heat. Evaporation of water. Guys, pay attention to ammonium. Whenever you see ammonium, it is endo. It will be endo, right? Because this is a salt that makes the water cold. You see, it's funny to think about it because when you put something in water, it is supposed to get hot, but somehow this thing makes your water cold, right? Have you guys done this in school? Did you guys do this experiment in school? I think you did, right? Most of you did, right? You just put this thing and then you use your thermometer and stir, and then this thing will just make your water colder. How cold did you guys get? Oh, you guys did it today. Okay, cool. How cold did it get? How many degrees colder? 27 ah. That means 1 or 2 degrees colder lah. Huh, so little ah. So little ah. During your birthday. Oh, happy birthday. Okay, so happy belated though. So lame ah. You guys only get like 1, 2 degrees ah. Oh, okay. Okay. Anyway, so melting, cold pack. This glow stick, please cancel. This is actually endo. Sorry, exo is already here. I don't know why is it here again. So please help me cancel it. Okay, guys, this is really easy chapter. I really don't want to spend much time here. So can we please go to our exercise? Can we please go to our exercise here? Chapter 5. Okay, guys, you know what? I'm not going to spend too much time here. As I said before, this is a really easy chapter. Guys, I have a question. Any of you here using BM notes? Any of you here using BM notes? Imagine you're using BM. Who else? Anyone else here uses BM? And I just noticed something. Oh, shall we, you too? Oh, Adam, you too. Okay. Hi, Adam. Is this my first time seeing you? Were you here last week? You prefer English, okay. Are you a new student or are you from Honey's class? Or are you from another teacher's class? Oh, you're new here. Okay, okay. What branch are you from, by the way? Okay, by the way, guys, if you're using BM, right? If you're using BM, oh, Puchong Tama, I see. Okay, if you're using BM, right? Yes, chapter 5 is missing. I don't know why. I think the printing team somehow gila already. Chapter 5 is missing. Okay, you see, I was scratching my head just now too because I had another Form 3 class just now. They told me, sir, I don't have chapter 5. I was like, huh? What do you mean? What do you mean you don't have chapter 5? Yeah, chapter 5 is missing. Oh wow, turns out that's the case. Okay, the whole chapter 5 is missing. So yeah. Yeah, just look at the screen, lor. That's the best thing you can do. Okay, I'm so sorry, guys. There's nothing I can do. I don't know why does it happen. So yeah, just look at my screen lah. Okay, anyway, guys, let's go to page 36 for the rest of you. Okay, question 9. Okay, question 9. Are you guys there already? Page 36. Page 36. Okay, shall we begin? So this is question 9. So those BM1, you can just look at my screen lah. I mean, it's not Bahasa Melayu as you can see here, but I'm sure you can understand most of the words here. Right, so number 9, Aiden carried out an experiment to determine the type of reaction based on temperature change. He added 5 grams of a substance to a beaker containing 100 cm cube of water. Right, so he has 4 cups of water. He put 5 grams of each of these into the water. The initial temperature of water before the substance was added and the highest temperature reached was recorded. Okay, so this was what he get. Okay, guys, let's look at substance A first. He started at 28 and the thing got down to 22. May I know what reaction is this? Yes, this is endo. Okay, cause colder ma. 28 to 23. Endo also. Okay, 28 to 33. Definitely an exo. 28 to 28. Yes, no change. This one is no reaction. Okay, maybe he's just throwing sand to water. Okay, there's no reaction, so there's no temperature change. Okay, number 1, let's look at number 1. State the substance that records the highest temperature increase. Which one has the highest temperature increase? Okay, it's a C. Thank you. Name the type of reaction for substance A based on the change in temperature that takes place. Explain your answer. What reaction is this? Okay, obviously endo. Hi Arun, how are you? It is endo. And explain. How do you know it's endo? How do you know it's endo? Temperature decrease, I accept. Temperature decrease, suhu menurun. Or you can say it absorbs heat. I accept too. Menyerap haba. Can also. You have 2 answers here. Okay, anyway, number 3. To ensure that the result of the experiment is valid, several variables need to be fixed. State the constant variable in this experiment. What's the CV here? What do you not change here? Guys, what do you not change here? Okay, no. I mean, what do you not change here? Mass of substance, I accept. Jisim bahan. Okay, by not changing, I mean what are the things that you do not change? Okay, this is the CV. Somehow this reaction just doesn't change. Okay, you can say mass of the substance. Or you can say volume of water. Okay, you can even say the initial temperature. We all start at 28. Can you see? Can you see? All starts at 28. Okay, guys. Can constant variable, your CV. Okay, next, number 4. It was found that the temperature of a mixed substance of substance B and water had returned to 28 after being left for 10 minutes. Hi, Mujun, how are you? Haven't seen you in a while. How are you? Okay, so after being left for 10 minutes, explain the observation and suggest how to slow down the decrease in temperature. Sorry, this should be increase. Okay, let's look at B. Let's look at B. Okay, what is happening now? What is happening now? When I add this to water, it goes down to 23. But why somehow it goes back to 28? Why? Why is this happening? Thermal equilibrium. Wow, yes, Jingy, that's a form 4 answer. Oh, that's a good answer. Okay, guys, you know what is happening here? After B has stopped, after the reaction has stopped, the temperature stopped decreasing, right? Because there's no more reaction already. So when there's no more reaction, this thing will slowly absorb heat from the surrounding and go back to 28. Because 28 is our equilibrium temperature. You know what I mean? You know what I mean? If let's say your room is 28 degrees, if let's say your room is 28 degrees, your chair, your table, the floor, your computer, your bed, everything will be 28 because they all stay at that equilibrium. So if you try to make something cold and you don't do anything to it, this thing will slowly return back. It's like taking a cup of water out from the fridge. Okay, let's say you take a can of soda, a can of Coca-Cola from the fridge. If you leave it there for 3 hours, that thing will return back to 28. Correct? It will return to the equilibrium because you stop doing anything to it. You stop chilling it. Okay, so the answer here, I explain the observation. Because you can see water absorbs heat from surrounding. Okay, air menyerap haba dari persekitaran. Or you can say even a better answer, this thing returns to thermal equilibrium. Oh, Jingy, that's a very good answer. That's a very good answer. Persamaan haba. So how do you slow down the increase? Let's say now I am 23 already. How do I make this thing will go back to 28, right? How do I make it as slow as possible? Let's just say I take a can of Coca-Cola out from the fridge. How do I make it stay as cold as possible, as long as possible? Come, guys. Wrap it with aluminum foil. Shouldn't it be an insulator? Compress. Why compress? No, nothing to do with it. Okay, guys, basically this question is asking you, what would be a good heat insulator? You get what I mean? How do I insulate this thing? Surround it with salt. Why salt though? Okay, the best thing I can think of is you can wrap the container with cotton. Okay, balut bekas dengan kapas. Okay, I wrap it with cotton. Why cotton? Because cotton is an insulator. Okay, if you don't want to say cotton, you can use cloth, paper. I mean, paper is not as good as cotton, but yeah. Yeah, polystyrene. Okay, or you can say mix the substance in polystyrene. You know, it's polystyrene. Your food container, your ice box is made from polystyrene. You know polystyrene, the white color foam thing. Why do we use that as our ice box? Because that thing is a very good insulator. Okay, basically they are testing you what is a good insulator to stop the temperature from going up too fast. You get what I mean, guys? You get what I mean, So number 5, Aiden repeated the experiment by mixing 10 grams of substance C with 100 cm cube of water. Predict the highest temperature that can be reached by mixture and explain the answer. What's the highest that can be reached here? I put 5 grams here, you see. So it got up to 33. If I put 10 grams, what would it be? How many degree increase here? This is 5 degrees, right? So if I put 10 degree, if I put 10 grams, yes, it will be 38. Theoretically it's 38, but maybe you won't get it in real life because you know things are not perfect like that. Explain your answer. Why is it higher? Why is it higher? Because more heat is released. Lebih haba dibebaskan. Hi Rui, how are you? We are in chapter 5. We're in chapter 5. What makes you late? You had dinner? Okay, so more heat is released. So when I put more stuff, I release more heat, so the temperature gets hotter. Lor. Common sense? Okay, common sense. Because more heat is released. Why can't we wrap with aluminium? Because aluminium is a conductor. Aluminium is a conductor, right? You see, if you're in winter country, right, would you wear aluminium? You wouldn't. That's why. Okay, that's why we use cotton to make our winter clothes. Okay, because it stays warm. All right, moving on. Number B. Oh my god, I hate this kind of question again. So Jimmy participates in a camp organized by his school. During the hot afternoon, he would like to have a cold drink. Unfortunately, ice and refrigerator are not available. You see, there are people like this. Okay. Build a container using the following items that enable Jimmy to enjoy cold drink. So what can he do? I mean, you look at these things, there's only one way to do this. So what do you do? See ammonium. Remember ammonium? Some of you did it today, right? This is the thing that makes your water cold. So you know what to do lah. Okay, so you take your container, put your canned drink inside, fill it with water, and put your ammonium nitrate inside. Hopefully, this will get cold. Okay, let me just tell you this won't. This won't. Okay, this won't get cold. But since he wants it, right, this is the best you can get. This is a freaking lame experiment. Okay. So, wow, this is a really lame question. Okay, so explanation. You can say water. Okay, we see the reaction. The reaction is endothermic. Okay, tinta balas adalah endothermic. Yes, it absorbs heat. Okay, so surrounding temperature decrease. Okay, suhu persekitaran menurun. So the drink gets cold. Okay, lame question. What do you want? Can't believe they asked something like this. Okay, right. Technically, it's still endoexo, so it's still in the syllabus. It's just that it's very lame. Okay, shall we move on? Shall we move on? Shall we move on? Okay, let's go to question 10. Let's go to question 10. Let's do one more before we move to electricity. We move to our the AC DC one, if you remember. Okay, so Jessica added a relatively large piece of potassium into a straw containing water. Wow, she's very brave. Potassium in water, wow. Maybe she has a death wish. Guys, I wish it goes without saying, doing this is freaking dangerous. Yes, the glass will break. I think I told you before, right? Potassium is freaking dangerous, so you don't do this. But hey, I don't know anything, right? Okay, because Jessica chose to do this. Right, so explain why Jessica's action is dangerous. Why is it dangerous? Because potassium is very, remember what we learned last week? Potassium is very good looking. So potassium is very, very reactive. Good. Okay, potassium sangat. Hey, what is it? What am I writing? BM. Say very, potassium is very reactive. Kalium sangat reactive. So what does it have to do? Okay, this chapter is about endo and exo, right? So how do we relate it back? The reaction is, does it release a lot of heat or does it absorb a lot of heat? Yes, This is exo. Okay, did not balance adalah exothermic. So large amount of heat is released. Okay, jumlah banyak haba yang dibebaskan. Okay, you might say, sir, heat only what? Heat very harmful, man. Heat will kill us, man. Guys, you have to know, all bombs is just very good heat maker. They are very exothermic in a very short time to burn you to death, right? Such is nitroglycerin. You know, it's nitroglycerin. Nitroglycerin is your dynamite. Okay, such is nitroglycerin. Such is your TNT. Such is atom bomb. Right? Basically, your atom bomb, atomic bomb, nuclear bomb, they are just very exothermic bombs that vaporizes you in split second. Right? Yes, you heard that right. It vaporizes you. I can't even find your body. It's that much of heat. Okay, 3 marks, huh? Is it 3 marks? Yeah, 3 marks. Okay, so B, conversation between Izzy and a friend. Zukri, why do we have to plant trees? Because we have to help reduce global warming. Okay, so according to him, planting trees will reduce global warming. Do you agree with Zukri's opinion? It obviously is a yes. Reasons why? Again, you have to link it back to exo endo. Why is it a good thing? Okay, so first tell me, what will plants do? What will plants do? Yes, plant will do photosynthesis. Okay, you ready yourself lah, huh? So photosynthesis, what's so good about it? What does photosynthesis have to do with global warming? Yes, it is endothermic. Photosynthesis is endothermic. So it, yes, absorbs heat from atmosphere. Okay, menyerap haba dari atmosfera. Okay, it absorbs heat from the atmosphere. So now there's less heat theoretically. So you have less global warming lah. I mean, the concept is that lah. But can we? You might say, sir, then why don't we do this and there's no more global warming? Yeah, it's not that easy. Okay, because you need a lot of trees, right? So, Adam and his friends sitting around a campfire. Why do they do that? Relay your answer with thermochemistry. Why are they doing this? What is burning doing? What is burning doing? This is exothermic. Okay, so it will keep them warm, produce heat, release heat to surrounding. Yes. Okay, so right. The answer is almost the same lah. Okay, write it yourself lah. Okay, so D I'm not gonna do because it's the co-pack thing again. It's the same thing. Okay, guys, do you have any question? Do you have any question about endo and exo? Should be okay, right? You should have no question here because it's so easy. Okay. Okay. If that's the case, right, then shall we go to electricity? Guys, do you need me to repeat the notes on electricity? Because we just learned this like last month. So it should be quite fresh to you. Do you remember what is renewable and non-renewable energy? Do you remember? Do you remember how to produce electricity? What did Michael Faraday say? You must have a magnet and a conductor. One move, one doesn't move, then you have electricity. You move the magnet, you don't move the wire, or you move the wire, you don't move the magnet. So we get electricity. Okay, remember all the power station, you hate electric, I know. Chloe, I know. All girls will hate electric. Okay, I will be surprised if you say, if as a girl you say, oh, sir, I love electricity. No, doesn't happen. Okay. Anyway, remember all these power station. Do you remember what is AC and DC? Do you remember what is AC and DC? DC is when thing goes in one direction. AC is when they go both direction. Okay, and the graph looks like this. So, do you remember what is a transformer? What is a step up transformer? What is a step down transformer? What is a primary and secondary? So when you have primary less than secondary, this is a step up. If you have primary more than the secondary, then it's a step down. Okay, can I? Can I? You know what? Since we have a little bit of time, okay, for BM notes, you guys have the notes, right? You guys have the exercise, right? This thing returns to normal already, right? Hopefully. Okay, so if that's the case, guys, I'll let you do something. I'll let you do something. Can we do some exercise? Just to, because we just learned this like 1 or 2 months ago, should be quite fresh to you. Okay, can you please do question 1, question 2, question 3, question 4, and question 7. 1, 2, 3, 4, 7. Okay, 1, 2, 3, 4, 7. Is 10 minutes enough? Is 10 minutes enough? Okay, cool. I'll give you 10 minutes, 10 to 15 lah. Okay, I'll switch on the cam later to give you the answer. Guys, don't wait for my answer. Please do it right now. Okay, I will see you in 10 minutes, 15 minutes. Okay, guys, are you done? Are you done? 1, 2, 3, 4 should be okay. Just 7 is a bit long. Okay, shall we discuss? Shall we discuss? Is everyone okay? Is everyone still there? Okay, yeah, good. Okay, good. Then let's look at number 1 first. The first one is your thermal power station. Okay, thermal because they burn fossil fuel. Guys, 80% of the world's power station is this. Because we are still 80% reliant on fossil fuel, unfortunately. Right? Guys, this is a very bad power station because it produces a lot of carbon dioxide. But hey, we have no choice. Okay? I mean, China is probably more than 80%. China is very reliant on thermal. They burn a lot of coal. Okay, arang batu. Okay, so this is your hydro. Okay, so nuclear generator will use radioactive stuff. Thermal generator will use fossil fuel again. Okay, next, number 2. Mark for the correct statement. Hydroelectric power generates electricity using flow of water from high to low. Yes. Number 2. Biomass generates electricity using steam from nuclear. No. Right? It actually uses steam from biomass. Okay, what is biomass? That means you burn dead animals, dead plants, animal shit, leaves, all the animal waste product. Okay, B, underline the correct answer. Power station burns methane from biomass. What is methane, guys? Methane is a gas that is produced when you ferment dead animals. Oh, you even get this in fart. Okay, you have methane in your fart. So technically speaking, your fart is flammable. The more you know. All right. So number 2, solar power station uses solar panel to convert light energy to electricity. Yes, it'll explode. No, say explode, it will burn lah. It's very flammable. Okay, it is very flammable. Okay. Chining, are you okay, Chining? Is your internet okay? Why you and your sister always like to disconnect one? You guys need better internet. Go upgrade your internet lah. Okay. Rui, are you okay, Rui? Wi-Fi sucks. What brand do you use? What telco do you use? Do you use Unify or do you use Maxis? Shijian, are you okay, Shijian? No idea. Okay. Right. So moving on. So number 3, who uses AC? It's your fridge and toaster. Okay, good to know. Right, guys. Fridge and toaster, they still use DC. It's just that we plug them to the wall. The wall uses AC. So in your aircon and your toaster, they will have a converter inside to change AC to DC. Okay. Hey, wait. Why am I connecting this to DC? Sorry. AC. Sorry. Brain fart. Okay. As for DC, if you notice, right, these things, they use batteries. So battery is definitely DC. Okay. Next, number 4 is this and this. This is a step up. This is a step down. Remember? And do you remember what is primary and secondary? Primer dan secunda. Primary is the thing going in. Secondary is the thing going out. Okay. So B, number of turns for primary coil is less than secondary for step up. Step up, primary less than secondary. So that's correct. Input is higher than output in step up. So step up, input is higher than output. So this is wrong. Okay. Next, number 7. Okay, number 7. Type of current. Dry cell will give you DC. Arus terus. Power supply will give you AC. Arus ulang-alik. So B, explain why both bulbs lighted up. Why both bulbs will light up? Why? Because both has current. Both have current flowing through. Okay, kedua-dua mempunyai arus. Okay, they have electricity flowing through them. Okay, we don't say electricity, we say electric current. Okay, when you have electric current flowing through something, that means the thing is alive. Okay, that means the thing is alive. So if you have a broken TV, they will usually, take off the TV and they will test the circuit board. There will be a circuit board inside. They will test for the current. If the circuit board has no current, that means the thing is dead. Okay, so C, state one similarity between the current supplied by the dry cell and power supply. That means what's the similarity? Guys, what's the similarity between DC and AC? How is AC and DC similar? How are they same? Can be measured. Okay, sure. What else? I can think of one. Both have electron flow. Okay, both have electron flow. Mempunyai pengaliran elektron. Okay, what about 2 differences between DC and AC? What's the difference? So many. Okay, direction. The first I can think of is direction. DC is one single direction. Satu arah. Whereas AC is both direction. Kedua-dua arah. Okay, what else? What else? Guys, did you guys do this? So what's your answer? Besides direction. Hey, let me ask you this. Can transformer work using DC? Yes, magnetic effect. This is what I want to mention. DC has no magnetic effect. The other Gerson magnet. Yes, both will produce heat. Both will produce heat. Whereas DC has magnetic effect. Guys, think about it. Transformer is a piece of metal. Yeah, sure. One is for small electronics, one is for housing area. Yeah, I accept too. You have to see, transformer is a piece of metal. It is a piece of magnet, right? So if you connect your transformer to AC, it will work because the magnet will switch on. It has magnetic effect. But if you connect it to DC, the thing won't respond. Guys, if you connect DC to transformer, nothing is going to happen. Okay, this is why, right? If you take your charger, okay, a phone charger has 3 pin, right? I actually have students asking me this. Sir, if I take my 3 pin, one I connect, these two I connect to battery, what will happen? Will my charger switch on? No. Your charger needs AC, which is from the wall. If you plug DC to it, nothing is going to happen. Okay, you don't believe me, you can try. Nothing is going to happen. Okay, so sketch the trace. Well, what do you see? DC, you will see a flat line. AC, you will see the line going up and down. Okay, it's like down, down. Wait. 3 boxes, 3 boxes, 3 boxes, 3 boxes. Okay, up, down, up, down. It means that this is both direction. That one is one direction. Okay, so guys, do you remember how to calculate this? Do you remember how to calculate this? Do you remember how to calculate your transformer? Okay, your VP VS equal NP NS. So can I reverse this thing? Yes, you can. VS VP equals to NS NP. Both, you will get the same answer. Okay, so up to you. See what you want to use. It's okay for both. Okay, so they tell you what is the output if the input is 10. If this is 10 volt here, what do you think is the output here? This one you didn't do, I'm just asking you. If this is 10 volt here, what about here? You see, this has 4 rounds, right? Yes, good. This has 4 coiling. This has 2. So it's half, right? So you get 5 volt. Okay, this is a step down transformer. Okay, guys, why will this thing not switch on? The voltmeter does not record any output reading. Why? Because it is connected to DC. Transformer requires yes, AC. Without AC, this thing won't work. Okay, your transformer needs AC. Okay, guys. Next week we will continue with our NGN, National Grid Network. We will continue with your housing electricity. What is 3-phase and single phase? What is your MCB? What is your 3-pin and 2-pin plug? What is your fuse? And how do you calculate your electricity? Your electricity bill. Okay, so guys, tahan for 1 more week. Next month, next week, October week 1, we will go into chapter 8. We will learn about nuclear. I'll tell you about who is Oppenheimer, what is the atom bomb. Okay, I will let you watch a video about nuclear. That's a very interesting chapter. Okay, you see, we finished the boring thing first, and then October we go into something interesting. Okay, so stay tuned for October. Next week we'll do 1 more revision, and then we are done for chapter 4 to 3, 4, 5, 6. Okay. Anyway, guys, do you have any question? Do you have any question? No? Okay, good. Then I shall see you next Thursday. Okay, nice to meet you, Bath. Okay, can I call you Bath? Okay. So I will see you next week. Have a good Thursday. I'll see you soon. Take care. See you. Good night. Bye.